Hey everyone, today's video is called Classification of Solutions, and really this is not very much different than what we've been doing. We still want to solve an equation for x. Notice I have my little list over here that I use to solve for x each time. And so let's go ahead and try to solve this one and see what happens, and you'll see why it's a little separate section that we're doing and why we're calling it what it is. Alright, so let's solve number one here. If we go down our list here, first thing we want to do is distribute. So we can see we have no parentheses. So we don't have anything to distribute. So really we're all done with this first step here. And then we want to combine like terms. Well, if I come over here and if I draw my t that we've been drawing right along here to separate both sides of the equation, I can see I have all my x's on the left side. There's no other x's to combine. There's no other regular numbers to combine. And over here on the right side, same thing. Alright, so really I'm done with number 2 over here. Number 3 says move all variables to one side. Okay, so that's really the first instance of any math that I have to do here. So I'm going to take this 5x and I'm going to subtract it on this side. And whatever I do to that side, of course I do to this side, just trying to get my x's on the same side of the equation. Alright, so 7x minus 5x gives me 2x, and I bring down the negative 3, and I bring down my equal sign, and right here this 5x minus 5x, that eliminates itself. Alright, they go away, and I bring down my 5. Okay, pretty straightforward so far. So now I've gotten all my x's to one side, and now just left is to do my algebra, solve for x. Alright, so first thing I'm going to do is add 3 to both sides of the equation. Alright, and again, remember, put these separators in here. It just makes it so much easier to understand what you're doing. So this negative 3 and this plus 3, they eliminate each other. I bring down my 2x, I bring down my equals, and 5 plus 3 is 8. Okay, and one last step here, I've got to divide by 2. Since this is 2 times x, I'm going to divide by 2, and I get x equals 4. Alright, so really that problem, nothing different than what we've done. We get x equals 4. If we do a check, that means I'm just going to take the original equation, and I'm going to plug in a 4 every place I see an x. So 7, plug in a 4 there, and 5, and I'll plug in a 4 there, and what I should get is the answers to come up equal to each other on each side of the equation here. So 7 times 4 is 28, and 5 times 4 is 20, and then I'm going to take 28 minus 3 and I get 25, and 20 plus 5 is 25. So there, it checks out. Alright, and you may be saying, well, why did we call this a different section in the videos here? And you're going to see in a minute, but this is called classification of solutions, and when you classify something, usually you're saying it's this type of thing or it's this type of thing. Well, this one, we got one answer for our equation here, and that's not always going to happen. Alright, we're not always going to get just one value for x. So this one we did. This is nothing really new. But the next one that we do, we'll get more than one answer, or maybe we won't get any answer for x. Alright, so let's take this one off, and let's put the next one up here, and let's see what happens for this one. Alright, we've got to go down our list again. As you can see, for number 2, there's no distribution to do, so I'm going to put a little check mark there. And I would combine like terms. Again, we can draw our separator here, and it looks like all the like terms are combined on the left side, and all the like terms are combined over here on the right side. So really we're done with that problem. So now we need to move all the variables to one side, and that's going to be the 7x's here. Well, I'm going to take away 7x here, and I'm going to take away 7x here, and this is where it gets a little different. Alright, so 7x minus 7x, well, they go away. and that just leaves me with a negative 3 over there. And I bring down my equals. This is nothing new. And 7x minus or plus 5, I'm going to take away 7x, and those go away. And that brings down a 5. And really at this point, I've eliminated all my variables. See, I don't have any variables left. So at this point, this is where the problem gets different. Is I just have to say to myself, well, does negative 3 equal 5? I'm going to even write that down here. Does negative 3 equal a 5? All right, does that make sense? Well, obviously, no. It doesn't make any sense at all. All right, so what has happened here is you've eliminated the variables from the problem. No more variables. All right, and what you got as an answer doesn't even make sense. Negative 3 does not equal 5. All right, in that case, if that happens, what you want to say is there is no solution. There is no solution for this problem. All right, meaning, all right, there is no number I can plug in for x here and plug in for x here, and it comes up true. It makes it work. All right, so if that happens, you eliminate the variables, you get an answer or a statement that does not make any sense. It is false. It does not work. Then this is your answer. There is no solution for this equation. All right, so that's why this section is called classification of solutions, because you're now, instead of just solving for x and saying, oh, I got one answer, which is fine, but other things can happen. So we're classifying this as an equation that just doesn't work, that has no solution. Okay? Alright, let's try the other one here. Turn on number 3, and let's see what happens with this one. Alright, same thing. We're going to separate the two sides here. Alright, and let's try to distribute. Well, there's no distribution to do. There's no parentheses there, so we're done with that. Combine like terms. Well, it looks like there's no like terms to combine here, and there's no like terms to combine there. Alright, so we're done with that one. And now we're to our move all variables to one side. So just like the problem before, this looks very similar to the problem before, but it's a little different. We're going to take away 7x here and take away 7x here. So those go away, and those go away. And what I'm left with is negative 3 equals negative 3. So again, very similar to the problem before, is that the variables, they eliminate each other, and I'm going to ask myself the same question. Oops, I got to take that out of there. I'm going to ask myself the same question: does negative 3 equal negative 3? Alright, well, yes, this one does. Alright, now if that happens, same thing as the one before. We eliminated the variables, and I'm just asking myself, does this make sense? Well, yes, negative 3 always equals negative 3. Alright, if that happens, then that means I have an infinite number of solutions to this problem. Alright, that's my answer. Alright, well, what does that mean? I have an infinite number of solutions. Well, infinity goes on and on and on and on forever. That means any value that I plug in for x, any number, will work in this equation. Alright, and let me show you. I'll do a little check here. Okay, if I have an infinite number of solutions, I can take any number. Well, let's take probably, the easiest number to deal with. Let's take 0. Alright, what if x equals 0? Alright, so let's try it. 7x minus 3 equals negative 3 plus 7x. Alright, well, let's plug in a 0. Plug in a 0 and plug in another 0 here. Well, 7 times 0 is 0. 0 minus 3 is negative 3. Okay, and 7 times 0 over here is also 0, and plus a negative 3, that's negative 3. And so I get what I got the equation before here. Negative 3 equals negative 3. Or actually, this equation. I'm talking about this equation right here. I get the same thing. Negative 3 equals negative 3. Alright, so it works. Alright, what if x equals, let's say, 20. Alright, let's take another pretty easy number to deal with. Alright, multiplying by 20, no big deal. So I'm going to plug it in again. Alright, every place I see an x, I'm going to plug in a 20. Alright, so 7 times 20 is 140. And again, 7 times 20 is 140. Well, if I take 140 and I take away 3, I get 137. Alright, well, if I start with a negative 3 and I add 140, even if you have to use your calculator for that, you still get 137. So again, the equation works. So this is what I'm saying. Any number will work for that equation. Alright, so now we have 3 possibilities. This is the main gist of this video, is we have 3 possibilities for an equation. Hopefully I'm going to spell this right. Possibilities. I'm trying to talk and write at the same time. Okay, so I could have one solution. I could have just one solution to an equation. Okay, or I could have no solutions. Okay, or no solution. Or I could have an infinite yeah, I can't spell today, infinite number of solutions. Alright, so when we say classification of solutions, this is what we're talking about. We could have an equation that has one solution, no solutions, or an infinite number of solutions. So we're classifying it according to the number of solutions that you have. So we may give you problems, and I say, well, not only solve for x, I may not even ask you that. I may just say, well, what kind of solutions are there? Is there one solution? Is there no solutions? Is there an infinite number of solutions? Alright, so that's why we're calling it, we're going to classify it according to the number of solutions. Okay? So there's your 3 different possibilities that can happen. We can make them, different kinds of equations and just simply solve for x like we normally do and see what we get and classify them according to this. So there you go. Thanks for watching and have a good night, everyone.